Okay, let's talk about stairs. um, Stairs can be very confusing uh, for the designer for a couple of reasons. One is when you're designing for a floor plan and you want to calculate the stairs, you're doing so based on finished measurements and designs. When you are calculating stairs for actual construction for a carpenter, now you're dealing with rough sizes and you have to take out the finish materials to figure out how to cut the stringers. So it can get very confusing depending upon what you're doing and what you're dealing with. So we're gonna go through. I'm gonna walk you through how the process is going to work as far as we're concerned here in this class. And the questions in the unit quiz over the chapter on stairs, and then there'll be another one on the final exam, uses rule number 4 um, in doing the calculation. And if you look on that page in the book, was it page 594 in the latest edition, 12th edition, I believe it is. I don't have my book here with me while I'm trying to do this. So, um, yeah, yeah, one of those things. Anyway, you can be reading through that chapter on stairs, and there's a number of different ways to calculate the riser height and the tread size. We're going to use rule number 4 so that we're consistent and it makes it so that I can ask you a question on a quiz and then you can make the calculation and answer it and come up with the answers. Okay. Now, the materials used in building a stair, of course, the stringer, which is the bottom part here that gets cut in this zigzag, that is typically a 2 by 12. That's normal. Okay. Uh, Commercial construction, it can be almost unlimited as to what you will find, but normally in residential it's a 2 by 12, which means it's 11 and a quarter inches maximum from the straight edge to that little corner right there, 11 and a quarter inches. Okay, now treads and risers. Risers are residential are typically 3/4 of an inch thick, and the height of it that it will be cut to however wide it needs to be. But they're typically cut from a 1 by 8. It could be a 1 by 10. It all depends. Okay, on the stair design. Now the tread, residential treads, I'll show you one here. It's a handy dandy Home Depot site. You can get them pre or unfinished in oak. You can get them in unfinished pine. Pine if they're going to be, you know, painted, which is rare to paint a stair, or like an unfinished stair going into a basement, or it's going to be wrapped in carpet, you would do pine. And there's all kinds of combinations available. Most residentials, they're 11 and a half inches from the straight edge to the nosing, and they're 1 inch thick. Now, commercially, you can get just about anything you want, but that's kind of the norm for residential. So that kind of sets the constraints on what we're doing. Now, this is not your house that you're working on. This is another project we had a couple of years ago, and I had a stair detail drawn out. Now, how do things anchor up here? This is the norm. Get you a bigger view here. This is not a great detail, but it kind of gives you an idea. You will have a riser at the top, okay? And you'll have a riser at the bottom. So it starts with a riser and ends with a riser. The main reason for that is they make a tread nosing, which is shaped like this piece right here, that fits over, and it's 3/4 of an inch thick here. And it's the full thickness here, whatever it is, 1 inch or 1 1/8. In this particular drawing, it's 1 1/8. If you have a carpet finish going on top, it could be done like this to where it's flush with the subfloor, okay? And then your carpet would just cover that and stop with a transition. Or if you have some kind of finished floor up here, wood, finish, then this nosing would actually be raised up and sit on top of the subfloor so that the top of this nosing is level with the top of your finished floor. Okay, this is why you need to know what kind of finished floor you have when you go to do your stair calculations. If you don't know, then you calculate based on the subfloor. Okay, so this is one manner in which, and this is the most common. You may see this detail in which the stair starts with a tread. Now this is highly unusual. Okay, simply because it is virtually impossible to get this to line up level. Okay, when you're talking about cutting these things and installing, this is really, really hard to do. So you very rarely see this detail in construction. Okay, so back to how we're going to calculate this thing. You start with, and you need the handout in class, okay? And your book may be useful too. I don't know. Okay, so we start with our total rise, okay, which is floor to floor, finished floor to finished floor. In my example here, it's 16, or excuse me, it's 9 feet. 9 feet equals 108 inches. Well, we start out, we divide that by 7 inches. That we just use 7 inches as a riser height, kind of a target to start with. So we divide 108 inches by 7 inches. It gives me 15.42. That's my number of risers. Well, I can't have a 0.4 riser. So I go back and I divide my total rise of 108 inches, divide that by 15. It gives me 7.2 inches for a riser. And then I divide it by 16. It gives me 6.75 inches. I go both ways on it. I round up and I round down, divide both ways, and I can kind of see, which way is going to be best. Okay, 7.2 inches is kind of tall for a riser height. It could work. Okay, depends on the situation. So we're just going to hang on to both of those numbers. Now, rule number 4 states that the sum of one riser and one tread should be somewhere between 17 and 18 inches. So what we do is we take both 17 and 18 and subtract both of those possible riser heights from that. So I take 17 minus 7.2 inches gives me 9.8. 18 minus 7.2 gives me 10.8. So I could have a tread depth of anywhere from 9.8 to 10.8 inches, and that work with a 7.2 inch riser. Now I do the same for the 6.75, and I come up with 10.25 and 11.25. So with a shorter riser height, I can have a wider tread. And that's the way the ratios of all of these things work. Residential treads are rarely greater than 10.5 inches in design. The reason for that, let's look at this. Now this example here is from an older project, and they're drawn in at 9 inches. Okay, so here in the red, this is one of those treads that I showed you from the Home Depot site. It is 11.5 inches from nosing to back, and it's 1 inch thick. And so I pulled it down and placed it into the stair here. Okay, and then I pulled it down here, kind of measuring. You typically want the nosing to stick out 1 inch past the front of the riser. That's kind of a norm. You don't want to try and meet the rounding tangent point here exactly. It's too complicated. So typically about 1 inch sticks out. Okay, and then you can see based on your design what you've got left. Well, when I measure, come on, from here to here, that gives me 10.5 inches that I have available that I can use. That's why I say residential treads are rarely more than 10.5 inches in design. In construction, they are, yes, but in design, no. Now, if you go into an unfinished basement, you can have a steeper stair, which would have a more narrow tread. Okay. Um, if your stairs are like going up into an attic, an unfinished space, you can have a steeper, a steeper stair, which has a taller riser, shorter tread. If you're doing a short stair, like might be between levels of a split level, um, you can have a deeper tread and a shorter riser. And these kind of push the rules a little bit, but those are different cases. So what we want to do is we want to pick a combination, a riser and a tread combination. And in this example here, it's using a riser height of 6.75 inches. Okay, so that means the number of risers that I have is 16 risers. Well, the number of treads is always one less than the number of risers based on our type of design that we're working with. Okay, so that means my number of treads are 15. And so to calculate the total run of my stairs, it'd be 15 treads times my tread depth, which in this example that I have here, for some reason the book directed a tread depth of 9 inches. So I'm just rolling with it as far as the video goes in the example. And so now my total run is 15 treads times 9 inches, which gives me 11 foot 3 inches, which you can see right here. Now, in your floor plan that you're working on, the bottom of the stairs is going to stick out beyond the opening that you have in the floor plan. Okay. So you don't have to draw a section like this, but in your wall section, you need to figure out this distance right here. Okay, you need to know the height from wherever that finished ceiling or wall situation is there, directly straight down to the tread that is directly below it. That has to be at least 6 foot 8 inches. Okay, now keep in mind, depending upon the tread depth that you choose, and I think 10 inches would probably work good for the floor plan for the project going. I think that's what we have used in the past. You're going to have a nosing that sticks out, a little bit beyond that. So where I measured, and you can always draw you a line down from there. I'm just going to draw a long to see where it intersects there. If I have a nosing that sticks over into that area, I have to measure from the nosing up. Okay. All right. Now, like I said, with design, we don't take the nosing itself into consideration when we're calculating tread depth. Our tread depth is from the face of one riser to the face of the next riser. Okay. And the riser height is from the top of one tread to the top of the next tread, or the finished floor to a tread. So the whole nosing and the thickness of materials only come into play when you're doing a design drawing of the parts similar to this. Now you have to take into consideration the nosing size and the thickness of all the materials. Okay, so I think between what I've covered here in this video and the handout, you should be able to calculate the stairs for your project house that you're working on. Okay, so there's two things that you need to do. Number one, you need to, once you've calculated your total run, you got to see where the start of the stairs are in your basement. Okay, and then modify your basement plan based on that. You need to see how much clearance you have here. If you do not have 6 foot 8, then you need to change your stair calculation to go with one fewer riser so that your stairs are more steeper and they're not as long. So you need to check this height. Once you have determined your total run, you're going to adjust your basement plan to show the correct location of the stairs, starting and finishing. And then based on your tread size, you're going to adjust both floor plans, basement plan and first floor plan, to make those changes, because we will be using your floor plans again later in the class. So those need to be done. And as far as this assignment goes, I will put into Blackboard how I want you to submit your calculations. Sound good? If you got questions, shoot me or shoot the instructor an email.